So my presentation is going to be, I guess, a little bit more applied to our kind of offering that we have, which we call the H2O AI Hybrid Cloud. So I kind of wanted to give a brief rundown of the individual kind of aspects of the hybrid cloud and some of the different areas that it addresses in regards to the machine learning kind of life cycle. So on the left-hand side here, we have this box called Make. So in here, you can think about some of the traditional kind of, things you deal with when you're modeling. So getting the data, exploring the data, engineering some additional features, then, of course, moving on to actually building the model. So, things like, hyperparameter selection, algorithm selection, things like that. After the model is built, or, kind of also during the model building process, thinking about ways of, interrogating the model so that way that the predictions coming from the model can be understood or interpreted. And then, kind of thinking about ways to create intuitive front ends for, users who are the target audience for the models to consume. On the right-hand side here, we have things that are kind of paired with Make a little bit later on in the process, which are, operate, where we're talking about machine learning operations. So deploying the models, doing things like monitoring, different things like that. And then on the Innovate side, this is the actual, creation and deployment of those applications that we created on the Make box to the target audience. So that way, all kinds of different users and business users across organizations can kind of use AI to drive business value. And I'll kind of touch on each one of the topics as we're going through here. So are there any questions right now? Okay, so I'm going to hop over to our H2O AI Hybrid Cloud. And if this is something that you're interested in playing around with, we do offer a free trial. And we can drop that link in the chat, or I can send it out afterwards if anybody's interested. So you can come here and play around with all the things that I'm going to show you today. So kind of the data set that we're going to be working with is kind of, I think, somewhat famous out there. It's a diabetes readmission data set. So just kind of looking whether or not an individual is going to be readmitted into the hospital within 30 days after discharge. And so if you're kind of coming into a problem for the first time and you haven't really had a chance to look at the data before, one thing that you might want to do is, an early kind of EDA to get an understanding of what's going on in the data. So in H2O AI Hybrid Cloud, here on the homepage where we're in the App Store, one of the apps that we offer is H2O Auto Insights. So if I click into Auto Insights here and I go to the instance I have running, I'll get a list of all the data sets that I've uploaded here. And I did run an analysis earlier on our readmission data set. I won't show that process just kind of for the sake of time, but I do want to show kind of what the outputs of the kind of Auto Insights application can be. So during the Auto Insights run, it's kind of going to dynamically look at all the different columns or features that you're interested in analyzing and present ones that are potentially interesting to you as a data user. So here, for example, right on some of the frequency analyses, we can see that we have some outliers here on the number of lab procedures. On the left-hand side, I have different options for looking at things for dimension by dimension, for categorical variables. I can look at measure by measure if I want to look at numerical versus numerical. And then I have things like clustering, which are a little bit more advanced, where in this case, Auto Insights was able to separate the data into two separate clusters that we can see here. And I have things that I can explore these clusters with, like cluster rules and parallel coordinates plots. I also have options for things like anomaly detection, and these are generated dynamically per data set. So these aren't stock that are going to be shown all the time. There may or may not be some that are in the data set or not. So there may be no anomalies. So maybe the anomaly detection for multivariate analysis doesn't show up. So this is kind of an easy way to get a jump start on your EDA. It can kind of springboard you into deeper analyses. But the nice part about this is it's generated automatically, so you don't have to worry about creating the code for the visualizations or anything like that necessarily. You kind of get to look at them as the end user and ask the fun questions about what might be causing certain things in the data set, or any of the analyses pointing to problems in the data set that I might want to fix before I move on to modeling. So I think we'll go ahead and move on to the next phase of the machine learning lifecycle, which is after we've done our EDA and we're starting to think about, taking the data sets to the machine learning space to actually build the model. In hybrid cloud, we offer, easy ways to provision compute for yourself. So that way you don't have to worry about infrastructure as a data scientist. You're just able to come in here and, for example, I can come to Driverless AI, which is our kind of flagship AutoML workhorse, and I can provision an instance for myself. So I can kind of specify the resources that I need depending on the data set that I'm dealing with and launch the instance. In this case, I have one running, so we don't have to wait around, and I'm just going to click into that. Once this is loaded, Driverless AI is going to drop us in the datasets page. We're able to load data from virtually anywhere, so no cause for concern there. What I've done is I've kind of preloaded the data set into Driverless AI. And kind of for the sake of time, I'm going to kind of not show everything and really just jump to modeling on data inside Driverless to really show how easy it is. So in this case, I've kind of split my data already, and I'm interested kind of in training on this trained data set that I have here. So I'll just left click on that and go to predict. And then I could give this a demo name. I could select the target column, which is, I want to know whether we're going to readmit or not. And then I can select, a test data set if I have that. We do support a variety of problem types. So in this case, we're looking at classification, but we also support regression, time series, NLP, image. Prashant kind of, touched on document AI a little bit earlier, which is in part backed by Driverless AI models. And then we also support unsupervised learning as well too inside Driverless AI. In this case, since this is our AutoML offering, we have different levels of automation that we could select for the model building process. So Driverless AI doesn't really handcuff the data scientist into a predefined workflow. You can choose to automate as much of the process as you want. So you could come here, easily load up a data set and click launch with the default settings. Or if you're a little bit more experienced and you want more control, you can come into the expert settings here and you can control kind of virtually every little aspect of the model building process. So everything from which algorithms do I want to include to hyperparameters about the algorithm. So things like tree learning rate and things like that. Or if you want to get really fancy, you can also create your own custom recipe, which is where you write your own custom code or custom logic in Python, and then you can actually import that into Driverless AI to bring in new models or new feature transformations that aren't necessarily out of the box inside Driverless AI. So it's a very extensible platform. In this case, I have an experiment that I already ran, so we don't have to wait here. So I'm going to go back to the experiments page, and I'm going to come into the experiment that I completed earlier. In this case, we can kind of see what a completed experiment looks like. So on the first thing I want to call out is kind of on the left-hand side over here in the bottom quadrant, we have a lot of yellow dots. And so what these yellow dots represent are individual models created over time steps. And so these yellow dots are the champion models for each one of those time steps. So you can kind of see as I hover over these different yellow dots that the variable or feature importance in the center is changing as Driverless AI is kind of using a genetic algorithm to engineer new features, select features, and select the algorithm and hyperparameters for the algorithms as well. So you can see over time, in this case, we optimize on AUC. So we see a steady increase in AUC until we build the final model. Just to give you some sense of how much feature engineering effort Driverless covers for us, we started out with about 50 columns of features, but at the if we look at the summary here in the bottom right, we engineered a little bit over 1,400 features, but the final model is only containing 235. So from a time savings perspective, right, not having to engineer those 1,400 features is quite nice for a data scientist. And instead, I kind of get to look at the final selected features and ask from a domain knowledge perspective if the engineered features that were selected or the original features that were selected make sense in the case of the use case that I'm looking at, or whether they're maybe pointing to an issue in my data or something like that. I'm also able to kind of get a visual overview of the the model that I built. So if I come to visualize scoring pipeline here, I'm able to see, in this case, it's an ensemble model across multiple folds. And I can click into the model here, for example, and I can see, if I just scroll in, all the features on the left-hand side and the feature transformations that they're fed to and in what order. I'm also able to, after I've developed the model, to actually interpret it. So we have a very rich machine learning interpretability suite in driverless AI. So if I click on show model interpretation on the completed experiment, it's going to take me to the MLI section, which again could be a talk of its own, which is, why we're going to briefly touch on it here, but won't spend too much time. But we do offer a lot of different options for interpreting your model, as well, again, for bringing your own recipe, and if you want to write some custom ways to interpret the model as well. Some of the things we offer are things like Shapley values, both on the transformed, so the engineered features, as well as on the original feature set as well too, which this is kind of a novel approach that we came up with here at H2O in order to kind of tie back the model predictions to the original feature space with Shapley values, which tends to be a lot more understandable in the domain space for the target audience for these models. So somebody who's a business analyst or something might not understand what target encoding is, but they would definitely understand the number of inpatient visits is the most important at predicting whether or not a patient's going to be readmitted again or not. This kind of makes sense because the patient has a history of being admitted. Makes sense that in the future they have a higher likelihood of being readmitted again. We also have things like partial dependency plots, which, if you're not familiar, just take the average prediction of a certain of the model against a certain column in the data set. So in this case, we're looking at the number of inpatient visits again, and we can see as the number of inpatient visits increases, the prediction goes up as well too, which is something that we would expect. We also offer things like disparate impact analysis and sensitivity analysis for debugging the model, what if scenarios, and things like fairness and bias. Again, I won't go into these here, but if you do sign up for the free trial, this is something you can certainly come in and play around with. So kind of the next stop on this, this machine learning lifecycle, if we think about the make, operate, and create boxes we looked at earlier, we're going to kind of move into the operate space now. So now that we've developed the model, I would like to be able to deploy it in a way that is easy and kind of immediately consumable. And in the past, this is where a lot of customers or just data scientists in general run into problems. Typically, a machine learning model might be prototyped in Python, then it has to be handed off to IT to be recoded in something that's a little bit more enterprise friendly before it can be deployed, and that often takes quite a long time to do that recoding. Inside of hybrid cloud, this isn't the case. So once we develop a model in driverless AI, I can create a project here in the project space. As you can see, if I come into the hospital readmission project, I've linked a lot of the experiments that I've done here, as well as the one that we were just looking at. Once I've linked the project inside driverless AI, if I come back to the AI hybrid cloud homepage, I can click on the My Models tab up here on the top. And this is going to take us to MLOps. So you'll notice kind of immediately on the left-hand side, all the projects that I had access to in driverless AI are also available here in MLOps. And if I click into hospital readmission, you can see, again, all those models that I had listed show up here immediately for me to be able to deploy. So if I want to deploy a model, all I have to do is come to the model I'm interested in, select the three dots, and then deploy to an environment of my choosing. The nice thing about this is that we're actually deploying the model as it was created, and it doesn't have to be recoded or anything like that. We don't have to worry about managing things like Docker images. All of that is kind of handled abstractly in the background for us. And then once a model is actually deployed inside of MLOps, what I get is a nice REST endpoint that I can then send data to. So here is just a sample request that we're looking at. On top of that, any model deployed inside of MLOps automatically comes with monitoring. So if I click on the alerts boxes here, I can see, let me log in real quick. I can see that we have a monitoring dashboard kind of created for us automatically. And we actually have drift detection applied as well too. So in this case, we're using PSI for the drift detection of the features as they're being passed in on live production data. So that way we can get alerts if the features appear to be drifting. So we can maybe look at retraining the model or other ways of dealing with that. Once the model is deployed here, the next step is really to kind of operationalize that deployment. So just deploying the model is not enough. We need to get the predictions in the hands of people who can actually leverage the value of AI to impact business decisions. So typically those users are non-technical in the sense of data science. So we would like to kind of create something that's a nice UI for them to be able to consume the predictions coming out of the models that we have deployed here. So that's where I'll come back to the hybrid cloud homepage. And we'll actually look at another application that was created using Wave, which is our SDK for creating all the Wave applications that we see here. And I'll click into the hospital readmissions app. Once we're here, we're kind of getting a brief summary of everything that we were just talking about. But what I'm interested in is kind of showing, the consumption side of things. So if I come to the prediction dashboard here, what I'll see is kind of, on the data that we're sending for scoring, I have, in this case, a histogram of the probability of readmission. I have the kind of top global factors affecting the readmission predictions that we're seeing here. And then I can see things like graphical representations of how the predictions are laying out geographically, as well as grouping by things like age, for example. What I want to point about these Wave applications is they're not templates where you can just fill in data and then have things displayed. They're fully customizable applications because they're written behind the scenes in pure Python. So even though we're looking at a web UI here, all the code underneath is nothing but Python code. So this allows you to create complex, complicated workflows as well as dynamic interactive applications. So this isn't actually a dashboard. I have a threshold slider here where I can control the confidence in the prediction before we classify somebody as being readmitted or not. So for example, if I slide this up to 0.7, you'll notice that the kind of readmission forecast by state falls significantly, which makes sense because we need to be more confident in a patient's readmission. Conversely, if I slide it down to 0.3, you'll see that this updates to show that we're having higher forecast per state here. I'm also able to come to the risk factors here. So if I'm maybe a clinician or something like that, and I'm trying to predict whether or not the patient's going to be readmitted, and I want to know why, if I sort down here to the most likely readmitted patient, and I click on that encounter ID, I can see the top factors impacting why the patient is being predicted as such a high probability of readmission. So in this case, the number of inpatient visits in the time period was 5 for this patient, and the number of emergency visits were 3. So this kind of makes sense as to why there's a high likelihood of a patient being readmitted. I can also, look at things like maybe the insulin level may be here. In this case, the insulin level was steady. Maybe there might be different diagnoses codes or medications that I as a physician can control. And we could even, in some future versions of the app here, recommend maybe different tactics that the physician can recommend to the individual patient to help, lessen that likelihood of readmission. So I think I'll stop here and open it up for any questions. I know that we're done a little bit early, but I know Prashant's talk also ended a little bit early as well.
There's a question in the chat, Travis. If you want to look at.
Yeah. What software architecture do we use behind Microsoft? Yes. So behind the scenes, everything that we saw here is actually on Kubernetes. So in our case, we're actually, the environment I'm in specifically is on AWS EKS, but we run on any kind of Kubernetes flavor, and we can also operate in a hybrid fashion as well too. So you can think about that as maybe multi-cloud or partially on-prem, partially on cloud as well too. We do offer REST APIs for everything that I've shown from the modeling perspective. So for example, if I come back here to driverless AI, anything that I did here in the UI can also be done through code using the Python or R clients. So if I want to code in RStudio or a Jupyter Notebook, I can write the code there, and then the commands are executed via a REST request to the driverless AI instance running. I also have APIs available for MLOps as well too. So if I need to automate or script deployment patterns, I can use the kind of API for that. And then of course, the models that are deployed as well too have that REST API endpoint that we showed earlier. I think I covered all the questions in that. Let me make sure though. For the data transfer, the data does have to come into hybrid cloud at some point, simply because when we're doing modeling, right, we need to load that into memory. So regardless of where it lives, it needs to go into memory at some point. So there does have to be a transfer to the hybrid cloud so that we can actually model on the data sets. In terms of actually modeling large data set sizes, that is not something that we have an issue with. We even offer kind of H2O3 clusters through the same provisioning piece that I showed for driverless AI. And we have customers that are using H2O3 to scale up to, terabytes or, in some cases, petabytes of data. So in terms of actually dealing with large data, that has not been an issue for us in the past. When we're actually scoring data for these deployed models, these are incredibly efficient deployments, typically with sub-millisecond response times for latency. So they're able to handle large, volumes of traffic. We have some, for example, financial customers that use some models for fraud detection. So these are, hundreds of millions of transactions a day going through some of our deployed models. I think that covers all the questions now. Is there anything else I can talk about?
Yes, I have a question regarding the data. So is there any pre-processing required before we send data to this platform, or like is there any specific template we need to follow?
That's a great question. So the format that the data really needs to be in is something tabular, but that doesn't mean that we don't support unstructured data. What I mean by tabular is that we need to have kind of an observation per row to associate with something. Now we do have unsupervised learning as well too, where you don't need a label associated with it. But obviously for supervised cases, you want a label associated with that observation. In terms of actually, cleaning the data and things like that, driverless AI will do a lot of that for you. So when I kind of showed the completed experiment here, part of the process, which we didn't see when we're actually running the experiment, is that driverless does a lot of internal checks, right? So for example, here it checks for and imbalance in the data set. If you're doing classification, it checks for drift between the train and test sets and things like this. It checks for data leakage. It can handle missing values and things like that as well too. Now, of course, you're always free to do as much data engineering as you want upstream before you bring the data to driverless AI for modeling. If there is, some domain specific transformation that may be useful, you can either do that upstream, or you can inside driverless AI, what I showed earlier, you can actually write a feature transformation for driverless AI to explore. So that can also be included in the automation part of driverless AI. Does that answer your question?
Yes, it does. Thank you very much. Yeah, I have a follow-up question.
Yeah, absolutely.
Yeah, for example, for now, you kind of like deal with the data like in tabular form, maybe in Excel sheet or a CSV file. So because when we talk about, for example, specifically in healthcare application, there are like a lot of data which cannot be used directly, which has to be processed, which could be in like document form or something. So is there any feature right now that you have, or do you have any plans in the future to support other forms of data, like maybe from images, maybe from like printed documents or something?
So we do already support NLP and image problems inside of driverless AI. So if I did have text data, like let's say, for example, I have a column in my data set that's a large block of text, we can handle things like that. So underneath expert settings here, you'll see there's options for NLP and image. We offer things like transfer learning here. So for example, in NLP, if you want to, apply a BERT model to, a data set that has a kind of, large text component to it here, you can use transfer learning to kind of, get the best out of BERT already and just kind of train that final output there on whatever problem you're trying to solve. The same goes for image as well too. We can also combine those data together. So you can have, relational data in the same observation as text and image data, and we can create a single model that considers all three of those together for a prediction. If you're looking for, maybe some more use case specific things, Prashant mentioned it earlier, and so did Bing Wei. The document AI application that we're working on too may also be of interest as well, as it's kind of, designed specifically for handling things like, contracts or, extended documents that might not fit as well into a kind of, modeling problem like this. So that's also an offering that we have as well too, coming up.
Thank you very much. I actually joined the talk a bit late, so I didn't know that.
Oh, no worries. More than happy to answer. Yeah.
Yeah. Seems
yeah.
Like
if you
have
joined
like
a bit
very.
late.
Seems like you have very diverse and robust features on your platform.
Yeah, our engineering team is pretty great. They put a lot of effort into it. And if you do want to play around with anything that you saw after you joined, you can come to h2o.ai/free. And you can just kind of, sign up to play around in the same environment that I was showing here. So you can kind of get a sense of, how the individual components operate and what you can do with them.
Sure. Thank you very much.
I think it's worth mentioning that for people who are not familiar with H2O, I think Travis, H2O core and the difference between H2O core and Travis AI, right? Travis AI runs on GPU, but it can also run on GPU. I understand it. I think it might be able to run on CPU now, but runs on GPU has a lot of benefit, right, for an auto ML piece. So
yeah, especially if you're dealing with text or image data, you pretty much absolutely need GPU to do anything productive.
Right. And I was going to ask you a question when you were showing the auto ML in Travis AI. When you do feature selection, well, when you pick the best model, do you also select the features, or do you use all the features, even for the best model?
Right. Yeah. So the features. So every yellow dot that we see here is a model as well as a combination of features and hyperparameters associated with that. So you can kind of think of it as an artifact. And there are multiple models built per iteration here, but we're seeing the champion models here as the yellow ones. And so, each iteration, there's a champion model with a certain set of features. And then kind of on the next iteration, the genetic algorithm introduces mutations. And those mutations are probabilistic in the sense that they look historically to see which features that were used previously to engineer new features were successful. And so those are considered the more fit genes and then carried, more likely to be used as engineered features going forward. So we do select going along as well too. And every time, we create a feature transformation and it's not effective, the features that were involved in it, there's a kind of a lowering of the probability that will be used again in the future. And then some of the features are actually totally pruned here using things like permutation feature importance until we get the final model, which, in this case, even though we looked at those 1,400 features overall, the final model only had 235 of them.
But the 235 has some engineered features and they are not all from a raw data set, right? Yeah.
Yeah, most of those are actually engineered features because the source data set only had 50.
Yeah,
so in this case, we're finding the most performance boost by doing some things that aren't surprising, right? So like there's some target encoding going on here. There's some clustering as well too, which is, a little bit more advanced. And then some things like numerical to categorical weight of evidence transformations. And you can see all of these in the auto report and full descriptions of them when you download that. So in driverless AI, we document the entire experiment process and give it to you in a Word doc that's typically like 36 to like 50 pages or maybe more, depending on the experiment. So you don't have to write any of that documentation, and you can kind of look through and get a very kind of clear picture of how driverless AI arrived at this final model inside of that auto documentation.
Yeah, thank you.
Mm-hmm. Are there any other questions?
Yes, may I ask a question?
Yes, please.
Okay, Travis, thanks a lot for answering my previous questions. Actually, I have another tricky question to
Sure.
pass on, actually. Some of my colleagues and I have been working on sort of a topic, it's turning AI into APIs. So I'm very impressed to see actually what you have done. It's like almost there. So when we worked on this topic, we received a very tricky question. And I think I want to pass on this question to you. I will translate a little bit. So because there are so many auto machine learning platforms. So why you developed H2O? Why do I mean, as a customer, to use your platform? And what makes your platform unique compared to the so many available auto machine learning platforms?
Yeah, absolutely. So first, I guess I would say that there are some things that we stand out in terms of the AutoML space that even a lot of other AutoML offerings don't have and compared to us. So for example, the feature engineering approach that we implement is mainly created by our Kaggle grandmasters that we have here, which I think now we have like over 20 of them. So the feature engineering inside driverless AI just out of the box is already very advanced. Also in terms of interpreting the model, so our MLI suite is also kind of industry leading. So a lot of people in the AutoML space will give you things like Shapley values and things like that. But there are some novel features that we have, like naive Shapley, for example, or things like K-Lime, which help to kind of transition people who aren't necessarily comfortable with giving over all of the kind of decision-making power to AI yet, until they kind of can understand why the model is making the decisions that it makes. On top of that, we're also incredibly extensible. So a lot of the other AutoML platforms make it more difficult to inject your own kind of either algorithms that you want to bring in, or feature transformations, or custom scores or things like that. Whereas we're very open to that in the platform from the catalog perspective, right? So these are all the open source ones that we have available that you can come and take a look at. For example, I want to import CatBoost. We wrote a CatBoost one here, but you could write any kind of algorithm that you wanted to, wrap it inside of our kind of class system that we have here for extending driverless AI, and then bring it into driverless AI and let it compete with the out-of-the-box models. On top of all that, when you start to think about deployment, almost all the AutoML providers out there kind of lock you into their platform for deployment. So even though I showed, deploying through our MLOps, kind of underneath the core scoring artifact that's there is something called the Mojo. So that stands for Model Object Optimized. And what that is actually a Java object. So I'm able to take it out of the platform because it's a Java object and deploy it anywhere I want to in any kind of environment, as long as I have a Java runtime environment there. So we don't kind of lock people into certain deployment patterns or into the platform for deployment once it's done. So there's really this kind of cohesive end-to-end notion of being flexible and extensible from not only kind of building the model, but then also deploying it. So I think when you add all those things up together, that's kind of where we the sum of the total is, it makes us clearly stand out from the other AutoML players, if that makes sense.
Thanks. Very impressive. And in addition to the free trial interface, do you have any demos like this? You just shown us so that I can share with my colleagues.
Yeah, we do have a lot of. Do you mean like pre-recorded ones, or would you like to have somebody from H2O come talk to you and your colleagues? Because that's something we can also do.
Yeah. To be honest, I'm frustrated when seeing the presentation of yours, because it seems that it's another example to prove that the industry people are doing much faster and much better than researchers. So
well, we do partner with a lot of academic institutions though as well too. So we have a large area of H2O that's kind of dedicated to that. So we'd be more than happy to even have a conversation with you. So we have a lot of things like AI for Good, for example, where we do some some help on the academic side of things with, you know, getting students and researchers like inside driverless AI to play around with, and, you know, things like that. So if that's something you're interested in, you can certainly follow up with me or Michael afterwards.
Sure, definitely. I'm gonna at least I'm gonna share the information with my colleagues first, and
yeah,
I believe
absolutely.
they will be impressed as well. Yeah. Thank you.
Mm-hmm. Is there anything else on the chat, or somebody that wants to ask a question or just have a conversation? I think we have a little bit more time left.
There's no question in chat.
Okay.
Just a few additional note why H2O, I think, started as open source, right? So
yes,
and everything is open source, and it's the module method is kind of a disruptor at the time, right? So module and Pojo, like Pojo is the old format. But,
yeah, that's plain old Java object. Yeah, that was wow, that's been a while ago now.
but
yeah.
The first advantage I saw is when you have a large data set, like a 100 gig of data set, there's no way you can use one server to process it, right?
Yeah.
But H2O solved this problem by running it in Hadoop with many nodes. I think it's 100 node limitation, right? So then you can start to process data that you cannot process in one server, and also train a model. So that is a great innovation in the first place. Yeah, then this serverless AI is like relatively new, right? Like in the past 3 years, right? Maybe.
Let's see.
Maybe more.
It is a little bit more than that, because
Yeah.
driverless AI was already here when I started, and that's at least 2 years ago now. So yeah, I think maybe it was 4 years ago or so. I don't, Prashant, do you know off the top of your head? I know you've been involved at H2O a little bit longer than I have.
Well, it doesn't really. I'm just saying. I started to use driverless AI like maybe 2-3 years ago. We start to have it, so I think it's great. So that's why. And now you have a full like line of products that can pretty much do everything. Yeah. This is great.
Yeah, we're trying to address like all the really common problem spaces that you run into, right, during the machine learning life cycle. Because only building the model, right, is only part of it. There's, you know, a lot of the other ones that we cover here as well too. So
right. So yeah, if Zheng, if you want to well, like Trevor said, I think there are some opportunity that cooperation with academic, right? Like for students or teachers, right? So I think, but definitely if you want to get more information, let me know also.
Yeah, sure. Thank you very much. But I need to talk to my colleagues first, because you know in Chile it's about, our work is about the astronomy, in the astronomy domain. So there are a large amount of AI technologies. I mean, the AI technologies are applied to the large amount of data. So they are also developing. They are also trying to implement the so-called turning AI into APIs, so they can easily share the functionality of the platform to use. But the current platform they have, or let's say we have, is pretty much poor compared with H2O. So I guess they will be impressed. I'm gonna share this with my colleagues.
Sure.
I mean, one thing we haven't really managed, this is Michael, I mentioned that the platform also goes beyond just the structured data, right? We also have image recognition. As Travis mentioned, we have unsupervised learning for unstructured data. We have a huge effort put into that area. you can even by using image and a couple of tricks even analyze audio data. So there's all different kinds of things you can do. And the big advantage of driverless AI is that we are allowing the ability to combine different types of data, right? Usually you have image classification or an image problem, then you only use image data, right? In our case, you can melt data like tabular data on observations, plus you can use image data, plus you can use NLP data and all different kinds of type of data to build your models and to melt that into one big setting, right? Which dramatically improves problem-solving capabilities of the engine, I would say, right? So that I would say that's one of the big advantages of driverless AI. Going just beyond one type of data, right? Travis, I have a question. Looking into the future, right? You talked about the machine learning lifecycle, which is great. So where do you think it's like we kind of have solved the business enablement through the technology side? If I can say that, right? We go from ETL and have a feature transformation. You can use raw data. We are able to automatically transform features, find the best algorithms, train it, build a scoring environment that is low latency. We have a deployment section that can deploy those low latency models. We can monitor those models, and we build API endpoints that you can use into a business environment and provide simulations and real-time decision-making through our app store and app low-code environment and in H2O cloud. So what is missing? So what are the next steps in your from your opinion? So are we there? Have we cracked the code and we're set, or is there what are the next steps?
Yeah, so I think that we've done a lot in terms of accomplishing that mission of democratizing AI, but there's still, I think, another component here. So even though we have like the ETL and things like that, kind of everything at the source goes back to the data, and so looking at the data that you actually have at the source, I think there's still like a lot of opportunity there for looking at bias on the data directly and things like that, being able to kind of serve features to the models that we deployed kind of appropriately, have historical versions of these kinds of things so that it's traceable and auditable. I think there's always more interesting things to do in the interpretability space as well too, for especially some of the industries where it's still difficult to deploy more modern AI models in some specific use cases. So I think there's still a lot of opportunity in those areas. I'm curious to actually hear what you have to think, Michael.
Yeah, it's gonna come up in 15 minutes in my talk. But I go beyond technology. But yeah, I agree. Thank you. That's a very good point.
Yeah, I guess if you're thinking about more beyond technology, to my last point, there's the human element is getting people to trust and work with AI in some areas, where they're not comfortable with it, where in other areas of their lives they already are, right? So whenever you do a Google search or something like that, there's AI behind that helping you find the best search results, which you're completely okay with, but maybe a model for like a lending decision or something like that might make people a little bit more uncomfortable. And so there's kind of like the human component to address there too, where how do we get people comfortable with AI so that they're working side by side with it and it doesn't feel like a replacement or something scary or dangerous.
Oh, that's great. That is a good bridge to my session. I appreciate that.